on your phones and computers. It's called iridium, and it's a rare earth element, but it's not rare for asteroids and interstellar objects. And so whenever we find a layer and it's rich in like iridium, but above and below it's not, we know that an impact or something from space came to Earth. No, what's up?
Have you heard of the Marinlink Crater right out in the bay? It's literally right off the bay from like I think DC.
No, I haven't.
It's like not very many people know about it, but there was an asteroid strike like 3 miles from like DC, I think.
If you can find that later, will you email me the answer?
Okay.
Wait, I thought the crater, they thought that was related to the extinction of the dinosaurs in South Mexico.
Yes, that's the Gulf crater.
If I were to major in astronomy, it would be mostly
Geology.
math, right?
There's a lot of math involved.
I wanted to
But depending on,
Already
if
got
you're
it.
interested in learning about it, but you don't necessarily want to like get into the math thing, we can talk later and I'll tell you about some potential jobs you can have that would help you learn about it and be able to use it in your life without needing to get into like astrophysics and rocket
Exactly.
There's a lot of like
The cool part, not the hard
Yeah. So anyway, I'm gonna go a little bit different direction here, and I want to ask you guys if you've ever thought about why there are no big mammals in North America. I'm talking like elephants. I'm talking pronghorn. I'm talking lions, stuff like that. Why aren't they here, but they're in Africa? Because what? It's not warm enough here? I don't know about that. Mammoths and mastodons live in some pretty cold climates.
Pretty tasteful. They have fur.
What about cheetahs too? Well, I'm here to tell you that they used to live here. This is a picture I took in California. These are tracks that are about 2.5 million years old, and they're about 1.5 times the size of normal, everyday, today lion tracks. And we found them in California. These belonged to, at one point in time, Sabertoothed Cats. Also, in that same canyon in California, we found tracks that belong to mastodons, or the relatives of elephants.
Whoa! And that's just there? Like you didn't have to do any digging or anything?
No. So, there used to be 13 species of elephants that lived in North America, 7 of which lived in Tennessee, and now there are none.
Have you found any fossils of them here in Tennessee? Oh, wait, you said camels, right?
In Tennessee, I don't know, but definitely in Arizona.
That's actually
and
probably
Mexico.
my brother question.
Camels, there's camel track. Picture I took in California from 2.5 million years ago. The camels walked through there. Horses. Horses also used to live in North America, and this is like, I'm going to get into this in a second. What's up?
How do you know that those are 500,000 years old?
So that's a great question. 2.5 million years. We look at the strata and we can put it together like. So in this particular part of the world,
It's preserved.
it's like savanna in Africa. The way that the climate is there, you have a dry season and a wet season. It's not so much winter or summer. And during the dry season, it's all mud and like caked dry mud, like kind of what we see here. But in the winter, during the rainy season, mud gets washed in and it fills in over those layers. And so what these are from is camels walking on the mud, and then it hardened during the dry season. And in the wet season the next year, there were floods that washed mud on top of it, and then other animals walked on top of that. And we can kind of reverse engineer how those layers were put into place and the different giant blocks of strata. And I don't know exactly how they dated it back to exactly 2.5 million years ago, but it's pretty sound dating. It's well agreed upon in the geological community.
That
So let's
crater's
talk about horses
in
for a
Chesapeake
second.
Bay.
I used to live in Oregon right next to this park called John Day Fossil Beds National Monument, and one of the things that they do there is they research evolution of animals. And the reason it's a really great spot to research that kind of thing is because it was really volcanically active. And so you have like, imagine there's this area, it's like really fertile, lots of animals living, thriving, mating, dying, all that stuff. And then volcanic activity came in and they were all choked out with ash and everything died and they were all buried. And then slowly it's recolonized by lichen and plants, things come back, more animals come in, they live, they reproduce, they thrive, and then another volcanic eruption, they all get buried in ash and die. And this happens over and over and over again. And what the scientists there have dug up is 55 million years worth of horse evolution. Back from the time when they had 5 toes and each one had an individual hoof on it, and pretty soon they lost a couple, they had 3 toes and each one had a hoof on it, and then later they had one giant toe that they walked on. Back to horses like we see today, but 13,000 years ago, they all disappeared from North America. They all died. They lived here for 55 million years, and they all died 13,000 years ago, and were reintroduced 500 years later by the Stone Age. 500 years ago, rather. To put that in perspective, if that 55 million years is your life as of right now, the horses all got wiped out 3 minutes ago. It was really recent. Happened like yesterday. So what happened to these animals? Here's one that isn't around anymore, and I'm glad. It's the short-faced cave bear. These guys were 6.5 feet tall at the shoulder. They weighed about 3,000 pounds. They could run 40 miles an hour, and they only ate meat. We call them hyper carnivores. That assembly we had this morning, we wouldn't have been able to have that if short-faced bears lived around here still today. And they lived in Tennessee. I don't know how people would have dealt with that animal.
Where is the nearest fossil found from here?
I don't know. Most of them that I have seen have been from the New Mexico, Arizona area, but that's just because I used to live down there, and I went and checked it out. But they used to live here in Tennessee too. What's up, Noah?
Well, my brother's a federal geologist for the U.S. Department of Energy in UGA. He's under UGA. And when we went to Rome, he was like, take one look at some of the seven wonders of the world. He's like, oh, that was built like yesterday in geology, and it just made me laugh. So.
No, this is true. I mean,
yeah.
Long periods of time aren't really that much at all. So we have the dinosaurs. We found the KT boundary. We know that they died from an impact event because we found the evidence in the rocks. We look back here, there were 13 different species of elephants. There were a bunch of different kind of pronghorn. There were giant sloths that wouldn't fit in this room because they were too big. All sorts of these animals, they all died out 13,000 years ago, and it just so happens that there's a layer that's almost exactly the same as the KT boundary we call the black mat layer. Below this layer, leading up to it, are all the skeletons of those animals that used to live here that are now dead. And above it, none of them. None of them. And when we start to look at that black layer, it's black because there's a lot of carbon in it, but we pulled out all the same exact things that we found in this layer that tell us that it's from an impact event. This was basically yesterday, guys. If we look at long periods of time, so far right side of the screen is 22,000 years ago, you'll notice you got some climate fluctuations, some temperatures, but then we're coming out of the coldest part of the ice age, which was like 16,000 years ago. We're climbing out of it. We get almost all the way. We're at a warming period that's comparable to temperatures today, but then it plummets. And the biggest drop happens right here, at the exact same time that we find all this evidence for an impact. The climate globally changed. The temperature dropped about 20 degrees Fahrenheit everywhere, basically overnight. Yeah.
Wouldn't it heat up?
Well, see, here's the thing. I'll tell you why it cooled off, but we have a warming spike here that's unexplained.
Oh, I see.
Unexplained. So my hypothesis, and that's just a guess, is that there were probably two impacts. One of them happened 13,000 years ago, and that's the one that cooled off the climate. It stayed that way for 1,200 years, and then maybe there's another one or something to heat up the climate equally as drastically, equally as swiftly, too.
What could have been looking at like a volcanic explosion that blocked the
Yellowstone.
What called the planet down rather than an impact?
I'll show you why,
I know which one.
Oh,
or how rather, an impact
Sorry.
could cool the climate. By the end,
I
if you
know
have-
it can, but it just seems like a little bit less likely than.
I'll show you the evidence in the
Okay, that makes sense.
Okay.
So.
No, you're good. One of the things that we looked at was different areas that has that black mat layer exposed, and all those different sites, we found the exact same thing. The exact same time, were laid out the nano